This section is called Counting Rules, and let's just jump right in with what is called the fundamental counting principle. So it says when we're interested in knowing the number of all possible outcomes when performing a sequence of events, we apply the fundamental counting rule. So this is going to look similar to the multiplication rule we learned earlier, which was referring to performing a sequence of events. But in this case, we're just going to be counting outcomes that are possible rather than dealing with probabilities. So let's take a look at the example. For breakfast, you can choose a main dish, eggs or waffles, and you can choose a beverage, coffee, tea, or juice. And we're going to take a look at how many different breakfasts are possible in this scenario. So we'll draw a tree diagram as we've done before, and this time just keeping track of our sequence of events where we're starting with choosing our main dish. So the two branches of the tree, when we pick our main dish, we could either choose eggs. We're going down the other branch, we could choose waffles. Okay. And then we're done with choosing our main dish, and then we go on and we can choose a beverage. So if we chose eggs for our beverage, we could choose coffee, tea, or juice. And if we had chosen waffles, our beverage choice, we would still have a choice of coffee, tea, or juice. Okay, so let's list all of our outcomes. So here are all the breakfasts we could create. We could have eggs and coffee, or eggs and tea, or eggs and juice. Or we could start with waffles. We could have waffles and coffee, a waffle and tea, or waffles and juice. All right, so we can obviously just count how many breakfasts there are. 1, 2, 3, 4, 5, 6. But the idea is, how could we know there are 6 possible breakfasts without always having to list all of these possibilities? So this is the fundamental counting principle. So how many main dish choices did we have? So we had 2 branches, 2 choices for main dish. And then for our beverage, the number of beverage choices for each of these 2 choices, we had 3 options for our beverage. So if we take 2 times 3, that's how we're getting our 6 possible breakfasts. So that is the fundamental counting principle. It simply says for every task or sequence of choices we make, we multiply the total number of choices for each of those tasks we're completing. So let's try this with making a BLT. So to create a BLT, you may choose whole wheat or white bread, iceberg or romaine lettuce, green or beefsteak tomato, and regular extra thick or maple bacon. How many different BLTs could be made? All right, so we could draw a tree diagram again, but now that we know the fundamental counting principle, we can jump right in and just start talking about how many possibilities there are for our choice of bread. So whole wheat or white, so we've got 2 choices there. And then we'll pick our lettuce, iceberg or romaine, 2 choices there. Tomato, green or beefsteak, 2 choices there. And then regular extra thick or maple bacon, 3 choices for bacon. So the fundamental counting principle says if we multiply all of those different possibilities for each choice we need to make, that will give us the total number of possible BLTs. So 2 times 2 times 2 times 3, I can make 24 different BLTs. Okay, so again, we're not going to list all 24 of those. I'll just give you an example of a couple. So I could choose whole wheat bread with iceberg lettuce and green tomato, and I could pick maple bacon. So that would be one option. I'd have 23 more options to go. So that's the idea here. We're just figuring out how many are possible. Rather than having to list all 24 possibilities, we're looking to just count possibilities. So that's why this section is called counting rules. So let's try another one, number 2. A sweater comes in 2 styles, 5 color options, and 4 sizes. And there are 6 yarns appropriate for the pattern. Disregarding color, how many different sweaters can be made with this pattern? All right, so we're not going to worry about color at all. We're simply going to take a look at options for the style, and there are 2 choices. And again, they say disregard color, but we do have to take a look at how many sizes. There's 4 sizes that are possible in the pattern, and 6 yarns are appropriate. So I would choose one of the 6 yarns appropriate to make my sweater. So if we don't worry about color, this pattern would allow us to make how many different sweaters? So we multiply. So the number of possibilities for each choice we make, and that should be 48. So I could make 48 different sweaters using this pattern. All right, so the way we recognize to use the fundamental counting principle is when we're making a series of choices. So let's try this one. Selma is studying the growth of a particular type of plant. She's testing the effects of 3 growth factors: lighting, age, and temperature. And the table provides the levels she is testing for each of these factors. She wants to find the number of ways of combining one level from each of the growth factors. So we want to know how many ways are there to do her testing. Okay, so the growth factor lighting, she can pick low, medium, or high light. So I'm just going to put here a 3 here. So there are 3 ways that she could choose her lighting. Age, 1, 2, 3, or 4 months. So she's got 4 possibilities or 4 ways to test using age. And then temperature, 1, 2, 3, 4. She also has 4 different ways or possibilities in terms of temperature. So all we have to do is say 3 choices for her lighting times 4 choices for the age times 4 choices for temperature, and that will actually give us 48 again. So this is also 48. So 48 ways in total of combining these factors. So again, just to make it clear what we're doing here, I'm just going to do an example. So I could list 48 different possibilities of combining these different factors. So let's say that I test in low lighting. So I could test low lighting, and I could test plants that are 1 month old. And I could test them at a temperature of 26 degrees Celsius. So that would be one of the 48 ways. And then again, we're not going to list all 48 ways. We could, but the easiest way to really visualize that would be to make a tree diagram, which would grow very large, because instead of ending up with 6 possibilities when we're done, we would end up with 48. So rather than listing all ways, we are just interested in counting how many possibilities are there. All right. We'll do one more here to introduce a symbol that some of you may have seen before. It's called the factorial symbol or factorial notation. So let's take a look at this example. In how many different ways can you run errands if you must go to 6 different stores in one day? All right, so you're running errands today. You've got 6 stores to go to, and we want to think about all the different routes you could take. So let me just first start with the same way we did this before. So when you're starting your day, if you have 6 stores to go to, there are 6 choices for the store you go to first. All right, so maybe you're planning on going to Trader Joe's this day, and you could pick Trader Joe's, but there are other stores, 5 other stores you do want to go to. All right, so you do have 6 choices. So let's just say you went to Trader Joe's. So when you're picking your second store, you're down to 5 stores left. So maybe you went to Trader Joe's, and then your second choice, you wanted to go to a grocery store. All right, so Trader Joe's grocery store. So you did have 5 choices, but now we're down to, for our third store, once we go to the first store and the second store, we'd have 4 stores left to choose from as our next store. And then we go to that store, we'd still have 3 choices for the next store. And then finally, we'd be down to just 2 choices. And then that 6th store, whatever is still left, is going to be that one store that will be our last store that we visit. Okay, so in math, when we start at the 6 and we multiply by decreasing 1 consecutively down to a 1, shorthand here, notation for this, we write 6 for the starting point, and then the 5, 4, 3, 2, 1, it's called 6 factorial. So the exclamation point represents this expression. So it's nice shorthand instead of having to write all those values going down. So I put an example here. If you had to go to 5 stores, 5 factorial, you start with the 5, and then again, consecutively, you're decreasing by 1 until you get to 1, and it's the product of those. And there's an equal with 3 factorial, and this is just really for reference. 0 factorial, it turns out to be 1, which really isn't relevant for us right now. But I just kind of put that in the notes for people that may be interested. Essentially, we are looking at values greater than 0. So 6 stores. Let's find out how many different ways there are. Now, of course, I could type 6 times 5 times 4 times 3 times 1 on my calculator, but let's show you where to find your factorial, that exclamation point. Let's show you where to find that on a calculator. So what I'm going to do is enter 6 first. So there's my 6. I'm going to hit my math button. I'm going to tab over here to probability. Oops, probability. And you'll see choice 4 there is your factorial symbol. So that exclamation point is a factorial. So I'm going to hit enter. And now I'll see on my home screen 6 factorial. So when we hit enter, it takes care of all that multiplication for us. And it's looking like I have 720 different ways I can plan my day. So that sounds like a lot. We only have to go to 6 stores, and yet you've got 720 choices for the order in which you visit those stores. So I'm also going to make a note here that in that total, right, we're keeping track of different orders. So I'm going to do my example, what I started with. So for example, I could go to Trader Joe's first and a grocery store second. Another option would be I could go to the grocery store first, and then I could go to Trader Joe's second. And then, of course, all the other stores. So the 720 ways means we're keeping track of the order possible when we visit the store. So I'm just going to make a note up here and say that ordering matters when we keep track of ways we can visit different stores. So we're going to come back to that phrase that ordering matters to us as we move forward into another group of rules that are under the general topic of counting.